In this tutorial, I'm going to review some very basic concepts about the immittance battery. I'm not going to talk about acoustic reflexes, but you should review this material as it's presented in the lesson notes as well as the text. What I want to do here is discuss some basic features of the tympanogram and some of the results that we can obtain from the tympanogram. On this slide, the top graph of the slide, I have a very basic tympanogram. What you should notice is that pressure is on the horizontal axis, so we go from negative pressures to 0 decapascals to positive pressures. And on the y-axis is the admittance of the system. And you'll remember when we're doing tympanograms, we are sweeping pressure from positive to negative values. And what we are measuring is the immittance of the tympanic membrane in particular. When we have positive pressure that is being introduced into the external auditory canal, admittance, or the ease of energy flow in the system, is relatively low. As the pressure begins to change and become more consistent with atmospheric pressure, admittance into the system is increased. And this is a key factor of tympanometry, and one that you should be sure you're comfortable with. That as pressure on either side of the tympanic membrane is equal, you'll see the greatest admittance or ease of energy flow into the system. As there's a pressure differential between the two sides of the tympanic membrane, the admittance of sound energy into the conductive system will be considerably less. So when we talk about a tympanogram, we're talking about this entire tracing here. We can look at the tympanogram and talk about particular values. One value that is noteworthy is static acoustic immittance, or peak Y. And peak Y is quite simply the height of the tympanometric peak. So how high is that peak? And this is the contribution of the middle ear system to the process of admittance. And you have this in your notes, tympanograms that have differing amounts of static immittance. And you should see that as we move from the top tympanogram down to the bottom tympanogram, static immittance decreases. The top tympanogram shows the largest amount of static immittance, greatest peak height, to a negligible peak when we get down to the bottom panel. All of these tympanograms show that the peak occurs at the same pressure. However, the compliance of the tympanic membrane, how much the tympanic membrane moves, how much energy is being admitted into the system, is what varies between these tracings. We can also look at tympanograms and classify them on the basis of their shape. One way that we can do this is if we say A is our normal tympanogram, two tracings, A sub D and A sub S, are related to static acoustic admittance values or compliance values that fall outside of the normal range. In A sub D tympanogram, the static acoustic compliance is above what's normally expected. The tympanic membrane is excessively mobile or compliant. In somebody who has a tympanic membrane middle ear system who has restricted compliance, we might see more of an A sub S shape to the tympanogram. We also can talk about tracings B and tracing C. Now tracing C, you should notice that static acoustic immittance isn't that different between C and A, the overall height of the peak. What's different here is where the peak occurs. For A, the peak occurs when we introduce 0 decapascals. You can ignore mmH2O. Think of it as decapascals. That means that the pressure on both sides of the tympanic membrane was equal when we introduced 0 decapascals. For C, we had to introduce almost minus 300 decapascals in order to reach the point where the tympanic membrane is maximally compliant. Well, what does this tell us? This tells us that the pressure in the middle ear is below 0. There's negative pressure in the middle ear space. This could be signifying the start of an ear infection. This could be signifying the end of an ear infection. The final shape in this classification is shape B. Shape B is also known as a flat tympanogram because there is no peak. The tympanic membrane is not able to reach compliance because there is some sort of fluid buildup perhaps in the middle ear space. And for the values of pressure that we can never present a pressure to the external auditory canal that would be equivalent to that within the middle ear space. And because we can't do this, we don't see any compliance peaks. The final value that I want to talk about is equivalent ear canal volume. When we're doing our tympanogram and we introduce plus 200 decapascals, we can get a sense of the overall volume of the external auditory canal. Remember